All right, here's the second part of the intro to RATEY notes lesson. For this one, number 3, we are going to start with the roots by setting the top equal to 0. There's no solving that we have to do here. It's already 0. So we're going to write this as an ordered pair and graph R 0, 0. As a quick hint, if your x-intercept is 0, 0, your y-intercept is also going to be 0, 0, but we'll confirm that with math when we get to that step. So A is for vertical asymptotes. You set your bottom factors equal to 0. We actually technically have 3 factors, but these two are exactly the same. Remember that this means x minus 3 times x minus 3. So we need to only set this one equal to 0 and solve one time. So x plus 3 equals 0, x minus 3 equals 0. Solving them gives me these 2 lines. So those are my vertical asymptotes. I'm going to go ahead and graph them. And again, they are dashed lines because they're not actually part of the graph, but they do determine behavior of the graph. Vertical asymptotes, your graph will cross it, or sorry, your graph will not cross it. Your graph will approach it and never cross it. So T is for tangent over together. So looking at our numerator, there are no squared terms, or factors, sorry, there's no squared factors. And in the bottom, we have this factor is not squared, this factor is. So what that means is at the asymptote we got from this factor, the graph will be coming together, meaning it'll be going either up on both sides of the asymptote or down on both sides of the asymptote. The direction on either side will be the same. So we're going to say, yes, that the graph will come together at x equals 3. And now that's just information that's going to hang out here till we're ready to graph. E is for end behavior. You need to make a ratio of your leading terms. Now, in the numerator, we only have one term. That is our leading term. In the denominator, we had to figure it out for ourselves. So just imagine for a second that I'm going to expand this squared factor right here. Now, we want the leading terms of the standard form. Right now, it's in factored form. So imagine that you FOIL this, get your solution to that, and then multiply it by this one, okay? That would give you your standard form. Now, we're only interested in the leading term, so we don't have to do all that math. We just need to multiply the leading terms of each factor. And that gives me x cubed. So that would be my leading term in the denominator. So when I make my ratio to figure out end behavior, I need the leading term from the numerator over the denominator. Now we look at our exponents and compare them to decide what to do next. They are not equal, so this is not a balanced situation. This is bottom heavy. So when you have a bottom heavy situation, your horizontal asymptote is automatically y equals 0. What's happening here is that end behavior determines the behavior of the graph only at the extreme ends, meaning as x goes to negative infinity and as x goes to positive infinity. It doesn't determine any of the behavior here in the center of the graph. So no matter what other terms were in my numerator and denominator, as x gets really, really big or really, really small, this bottom thing is going to be more important than this top value. It's going to get super, super, super big on the bottom, which means it's getting closer and closer to 0, either positive or negative. And that's why your horizontal asymptote will be y equals 0 every time you have a bottom heavy situation. So let me graph that. And then for the y-intercept, we already know it's going to be 0, 0, but I'm just going to sort of prove it to you, confirm, by plugging in 0 for x down here. And whatever we get down there, since we have 0 in the numerator, this is going to simplify to 0. Okay, and now we start graphing. And I always start in whatever section of the graph I have the most points. that I already know. So that would be my center. And I only know one graph. And so here's what we've talked about. This graph has two asymptotes, so there's going to be three pieces. We talked about how the end pieces here is going to be some version of this shape, maybe rotated around, but that basic shape. And then the shape in the middle is going to be some version of an x squared shape or some version of x cubed, maybe reflected, but that basic shape. And now we only have this one point, and that's not enough information to figure out which of these centerpieces I'm going to have here. So the way we can fix that is we just find a test point to determine where the movement is going to go. So you can pick any x value here. Do yourself a favor, make it an easy, like don't pick 1.672 because that would be complicated and then necessarily stressful. So I'm just going to pick x equals 1 and find the y value for that. So I'm going to plug in 1 where I see these x's in my original function. Follow your order of operations. And I get 1/16. So I know I'm going to have a point at 1, 1/16. I know that's very, very small. Most importantly, I know that it's positive. And so if I go over 1 and up in the positive direction, that is enough information that I need to know that this graph is going to be going this way. So now my next question is it going this way in tangent at the 0, meaning I'd have this an x squared situation, or is it going to cross through like a x cubed situation? And here's where you go back to your t. You see how it says none in the numerator? That means it's not tangent at any of the roots. That's how I know it is not going to bounce and come up. It's going to cross through instead. So I have this basic shape here. If this had been squared, if my this was squared, then I would say yes, tangent at that point 0, 0, and then this shape would have bounced here and gone. It would be tangent and would have made a U shape, okay? So that would have been the difference with a squared term. And then for this last one, oh wait, sorry, we have to finish this, okay. Sorry, I haven't finished my coffee yet, it's this morning. So now we are talking about the end pieces. We know it's going to be this basic L shape. I know that it's going to come together at the asymptote x equals 3. So that's this asymptote here. Together means same direction on either side, because as x is coming into that asymptote, the y's are coming together. So, and it's going to be approaching this horizontal asymptote, but never crossing it. And it's getting smaller and smaller and smaller as x goes out to infinity. And then on the left side, at this asymptote, it is not together because that factor that gave me that asymptote is not squared. So not together means not the same direction on either side, but the opposite direction. So if it's going down to negative infinity on the right, it's going up to positive infinity on the left. And then as x goes to negative infinity, it's approaching that horizontal asymptote, but never actually getting there. And so that's my basic shape. All right, so for this last one, feel free to pause the video and try this one yourself, and then come back. So set the top equal to 0, solve, write it as an ordered pair, graph. For the vertical asymptote, set the bottom equal to 0, solve, write it as a line. Graph, that is 1.5. T, tangent over together, we are looking for any squared factors, and I don't see any. So this is a none situation. end behavior, make your ratio of your leading terms. So 4x over 2x, the x's cancel, 4 over 2 simplifies to 2. This is the value of your horizontal asymptote. This is a balanced situation. The exponents are equal. When that happens, you simplify, and whatever value you get is your horizontal asymptote. All right, the y-intercept we already know is 0, 0, but just for consistency, and so you can see the math, how to do order of operations. There's no parentheses to simplify, there's no exponents, so I go to my multiplications. 0 over negative 3 is 0. All right, so here I am. I'm at this graph. I have one point here. Now, there's only one vertical asymptote, so I have no middle section. I have only two ends. And so I know that they're both going to have this basic shape here. So I don't need to do a test point just to sketch the basic shape. I already have this point here. And in this quadrant, I know that it's going to have to be that basic curve. So it's just going to go like that. And then to decide, so my two options for this right side are I either have an L shape here or an L shape here. And how do I determine which it is? I look at my t-step in the denominator. It says I have none, meaning no squared terms. So I have no situations where it's coming together and going the same way. So if it's not coming together, it's going apart. So if I already know it's at this asymptote, it's down on the left, it's going to have to be up on the right. So this is my final shape right there. Okay, and that's it.